Hi guys! Well, I couldn't be in class today because I'm at a training right now, so instead you're going to get one of my fabulous videos. So let's start at the top of the page. When we say that one figure is congruent to another, we mean that there is a rigid motion that maps the first onto the second. So if you have a rotation, a reflection, or a translation, any one of those, it means that the first figure will be congruent to the second, the pre-image and the image. The rigid motion maps each part of a figure to a corresponding part of the image. So hold on a second here, there we go. It's kind of hard writing with a mouse. I usually just do constructions for my videos, so now I have to actually use the mouse to do this. Okay. So, yeah, you're going to hear me say the word corresponding a lot today. If I go any faster, it's going to be sloppy. Okay, corresponding. There we go. So now we are on my favorite website, GeoGebra, and I'm going to show you exactly what is meant by congruence. So here we have a rotation. It was a 240-degree rotation about this point right here. And if you look at the corresponding sides, I know it might be hard for people in the back to see, but for example, AC is 10.75 and A prime C prime is 10.75. They have the same length. If I go to the angles instead, I'll just choose one angle. Angle B is 60.52 degrees and angle B prime is 60.52 degrees. So what you get is all of the corresponding, meaning in the same spot, all of the corresponding angles and side lengths are equal. Well, if that is true, now instead of saying equal, we can say that they are congruent. Basically, anytime we have ever said the word equal, we are going to change it to congruence. So remember what it said, that you have to have a rigid motion in order to have congruence, and here we have our rotation. So what should always happen if you have congruent figures is if you take the two figures, which I'm showing you now, and put them right on top of each other, they're going to be exactly the same, and that's what ends up happening. So not only for the rotation, but it's going to happen for the translation too. So here's our triangle that's already been translated along this vector AA prime. And if you look at the side lengths, the same thing's going to happen. Let me make the triangle a little bit different here. So if I change it around, okay, so I made it a little bit bigger. So you can just look at corresponding sides. BC is 16.89. And I don't know why they label it as triple primes, but this corresponding side, B triple prime, C triple prime, is the same, 16.89. The same can be said for any of the corresponding angles that you go to. 76.63 degrees, 76.63 degrees. So again, because there has been a rigid motion that was performed, a translation, these two triangles are congruent, meaning if I take the triangle back and put them on top of each other, they are exactly the same. And last but not least, we have our reflection. So if I click on the corresponding sides, you'll see that they have the same measure. If I click on the corresponding angles, again, they're going to have the same degree measure. So what will happen, being a reflection, which is a rigid motion, is if I flip the triangle back and put it right on top of the other one, the two triangles are exactly the same, meaning they are congruent. So from now on, when you think of congruence, think about that. Can you take the two figures, put them on top of each other, and all the sides and angles will be exactly the same? So let's go back to the worksheet. So 1A asks us to describe the rigid motion that maps triangle ABC onto EFC. If you look at the ordering of the letters, it's actually really important here because the first letter A will map onto the first letter there, E. So A is mapping to E, the middle B is mapping to the middle F, and C is just going to stay as C. Okay, so when we look at this, using those letters, we can tell that a rotation took place. So we have a rotation. But remember, just stating a rotation, that's not really describing it. We have to give more information. So it's a rotation of, now let's get the angle of rotation in the center. We can tell that the center of rotation is going to be point C. So to get the angle of rotation, connect, for example, it's actually already done for you, but I'll just trace it here. If I connect B to the center of rotation. And now I'm going to go back to looking at A to see, okay, where does B map to? B is the middle letter. It maps to F. So if I connect B to the center of rotation and then F to the center of rotation, make sure you're going in a counterclockwise direction. You can see that that angle is 90 degrees. So we have a rotation of 90 degrees about point C. Okay. So next it asks for us to identify all 6 pairs of corresponding parts, because once a rigid motion takes place, now you have 3 angles, 3 pairs of corresponding angles that are congruent, and 3 pairs of corresponding sides that are congruent. So let's do the angles first, meaning the vertices, the corners. You can actually, you might have to look above again, looking at the order here, like A maps to E. Okay, so just go in the diagram. So angle A maps to E. So they are going to be congruent. They are equal. Whatever the measure of angle E is, it's exactly the same. A is the same as E, so we can say angle A is congruent to angle E. Now, if you look at that, hold on, I'll put it up above here a little bit clearer. This symbol means congruent. So instead of writing equal from now on, we are going to write congruent. Okay, so let's keep going here. So B, if we perform the rotation, is going to map to F. So angle B is congruent to angle F. And the last one is, you don't want to say angle C is congruent to angle C because these are in 2 different places here, okay? So how about we put a 1 in there and then a 2. This angle 1 is congruent to this angle 2. You could use 3 letters, B, C, A, F, C, E. That would be fine too. It doesn't matter to me what you do. I'm going to put in 1 and 2. So angle 1 is congruent to angle 2. Okay, so that's the vertices of the angles. Now we're going to do the corresponding sides. So when you rotate this, I'll start with CB. If you look at side CB, the ordering of the letters is really important here. It's kind of the important part of today's lesson. CB, I think everybody could probably tell after the rotation, it maps onto this side here. It actually does matter if you say CF or FC. We're trying to list the corresponding side. So if I list C first, then the first letter over here has to be, well, where, after the rotation, where does C end up? Well, C stays where it is, so C is going to stay. And then the next letter is B. So if I go to B, okay, where's B going to end up after the rotation? After the rotation, it will end up with F. So CB is congruent to CF, corresponding. List them in the same spot. Okay, let's do the other side. How about BA? It doesn't matter how you list it first. It just matters how you list it on the other side. So BA is congruent to, okay, BA, now I have to list B first. B, after I rotate it, goes to F. And A, after I rotate it, goes to E. Okay, one more. So the last one is CA, or AC. It doesn't matter how you list it here, just on the other side of what it's congruent to. CA. Okay, C, after the rotation, stays where it is. So C maps with C. A after the rotation maps to E. Okay, so this is what we got so far. One more part here. Use the properties of rigid motions to explain why triangle ABC is congruent to EFC. Like, how do we know those 2 triangles are congruent? Well, when you have congruent triangles, all of the angles are congruent and all of the corresponding side lengths are congruent. But just saying that doesn't have anything, it's not specifically relating to rigid motion. So here's what you need to know, and you guys know this, we've written this many times before. If it says to use the properties of rigid motions, always state what rigid motion it is, so that's specifically a rotation, and we are going to say, I got to write a whole sentence out, I feel like this is going to take a long time. Okay, rotations, I'll try to go faster and keep it neat. Okay, rotations, Sean, are you listening? That's for my 7th period class. Okay, rotations preserve, what do they preserve? Say it out loud. Yep, that's right. I hope somebody said it. Okay, rotations preserve distance and angle measure, right? The distance stays the same. That's how we have the congruence up here. And the angle measures stay the same. That's how we have all the congruence here. So I'm saying the distance and angle measures preserved. That's why the two triangles are congruent. Rotations preserve distance and angle measure. You could say, I'm using the symbol. I can't write. I'm going to have a cramp in my hand soon. You guys have no idea what this is like, okay? There. You could say rotations. Wait, how do you guys say it? Distance and angle measure is kept? No, but you have to say rotations. Sean, I don't know how to word this. Rotations are keeping distance. Okay, I don't know, but Sean, you got to tell me how you would write this in your language. Okay, so there we go. Pretty exciting, right? Yeah, it was. Okay, let's do another one. Number 2, in the figure below, the triangle on the left has been mapped to the one on the right. Part A describes the rigid motion. It looks like it could maybe be a rotation or a reflection, but you have to look at the markings. This single marking on DE and then this one here on GE, those are congruent to each other. Okay, let's not say equal anymore. Those are congruent. So the only way I could get those two sides congruent is if it's folded over, meaning it's a reflection. If I rotated it, that came out weird. If I rotated it, this single marking would land on the double one. Well, the doubles are congruent to each other, and the singles are congruent to each other. So the only way to get this is a reflection. Reflection. But we have to also give the line of reflection. My mom made this pumpkin dessert. It's like a pumpkin cake with chocolate chips in it. Ooh, that was a bad end. I'm really excited to eat it, so I have to get through this video. This is my goal. Get through the video, then I get a reward. Okay, so it's a reflection. I gotta say something weird, right? I'm sure you guys are getting bored. Reflection over this segment. Usually it's a line, but in this case it's going to be the side of the triangle. EF. It's reflected over EF. And let's put the segment bar over it. Okay. Identify all 6 pairs of corresponding parts. Let's do the vertices first. Now, let's do the one that's marked in already, like the double at D and the double markings at G. So D is congruent to G. They're the same angle measure. So angle D is congruent to angle G. And there. Okay. How about the single markings? Now, don't say F is congruent to F because these are two actually different angles. Like, they're the same degree measure, but they're not in the same exact spot. So let's just make it easy and go 1 and 2. Angle 1 is congruent to angle 2. And then the last one, which is not marked in the diagram, is up on the top here. It's angle 3 and 4. Again, you can't call it E because they're two separate angles. So angle 3 is congruent to angle 4. Remember, you can use 3 letters if you would like to. That is totally fine. Okay, there's our vertices. Next to the sides, let's do the single markings first. ED is congruent to, meaning it's the same length as, now if you imagine folding it, reflecting it, what's ED going to map to? To EG. E would stay where it is, and then D goes to G. Okay, next, how about the double markings? DF on the left, DF is congruent to GF because D would map to G, so D goes to G. Oh, okay, I need a better G. G, there we go. D maps to G, and then the second letter F, well, F's just going to stay where it is, so F. Okay, last is this side right here. The left triangle and the right triangle both share EF. It's going to just stay where it is after the reflection, but that is the last side that you have to list. So you're listing like EF, talking about the left triangle, is congruent to EF in the right triangle. EF. Okay. Last but not least, part C. Use the properties of rigid motions to explain why the two triangles are congruent. How do we know the triangles are congruent? Well, first of all, whenever it says about a rigid motion, list what the rigid motion is, so we know it's a reflection. And we just talk about the two things that are preserved in a reflection. What two things are preserved that would make the triangles congruent, make the triangles exactly the same? Reflections, preserve, distance, and angle measure. Both of them, which again we showed on this whole chart that we completed. Distance, I'm getting towards the end of the video. Oh, that's off the page. Wait, how could that be? Yeah, never mind. Okay. I was thinking it would be off at the red line. I don't know. Distance, and I'm going to write in cursive just to see what it looks like with this mouse, okay? I've never done this before. This is a big moment. Angle. Oh, it's not bad, huh? Maybe my cursive is better than... Oh, it's getting... Oh, my hand's hitting something. Oh, my gosh. I got to... Hold on. Oh, did you hear that squeak? Okay, I had stuff in the way. Wait, this needs to be fixed. Okay. Really focusing now. Okay, that wasn't a... That... Oh my gosh. Measure. There we go. That's a great ending to this video. All right, guys. I will see you tomorrow. And right now, you're going to finish the rest of this worksheet. Make sure when you do the last problem on the whole sheet, you draw a diagram. Otherwise, you won't be able to do it. Bye.